The standard mates offers quite a few different mate types for setting something in a specific place. If you want to have motion within your assembly, within limits though, you'll have to use advanced mates or mechanical mates. In this case, we'll be talking about advanced mates. So the first thing I want to do is create multiple of these tabs that we're going to be mating in. And I'll just go ahead and hold down Control, click on the part, and drag it out. And I need two of these small versions, and I'll right click on one of these and go to Component Properties and choose Large Slider for one of them. Now I want to mate each of these into the slots here. And I could go in and do a coincident mate, and that would work just fine for both of these sides. This part has been modeled to fit coincident into the slot, whereas the other tabs, if I choose coincident and click on one of the faces, you'll notice from the side there's a little bit of a gap, and that was intentionally modeled that way because instead of the coincident mate, we're going to be using the with mate within the advanced mates. And what the with mate allows you to do is it allows you to select two sides of a component. So in this case, for my with selections, I'm going to choose those two faces. And for the tab selections, I'll go ahead and select one of those faces and the other inside face. And that's going to put that in the center between those two faces. So the gap is maintained on both sides. Next, I'll go ahead and make this coincident on the bottom to the top of the plate. And I'll go ahead and add in another with mate. And it doesn't matter which component you put into the tab selections and which component you put into the with selections. As long as you're selecting two faces out from each component, it'll figure it out. And once again, I'll want to add a coincident mate to the bottom of that face now and the top of that face. And let's drag it over to get it out of the way. And I'll just go ahead and repeat the process. For the other two tabs. Once again, the with selections. And the tab selections. And just to demonstrate, if I were to select the opposite sides instead, this will center in on those two faces instead. And we'll still be able to slide back and forth. I'll go ahead and hit the undo, and that'll undo that. And we'll choose to add another with mate. Once again, we'll choose the two sides, and we'll set our tab selection. And click OK. The last with mate I want to add is going to be between this lever and these two tabs. And I'll go ahead and make these two cylinders concentric. Now that we have those with mates added in, we can see that this will move along, or this will slide along that slot, but it won't stop at the ends. For that, we're going to need a limit mate, and that's once again in the advanced mates, and we want to limit the distance, and this works the best with flat faces. So we'll choose out these two faces, and the top box is going to be the starting position. This actually isn't really important for the mate since you'll be able to drag it through this anyways. But for min, we want to set this as 0, and we'll just take a look at what 0 looks like by entering it into the top box. That's directly coincident. And then we want to add in the correct distance to get that to be coincident, which in this case is 1.4. So once I click OK, I can drag this back and forth. Next, I want to do the same for this slot. Once again, I'll choose these two faces. And maybe I don't want it to go the whole way. So maybe I'll say 1/4 inch and 1 1/4 inches. And let's see what that looks like. So I might want a little bit more motion to the right. So I can just come back in, make this 1.75. And that should be fine for now. Now, rather than set up a limit mate here, let's say we want these two parts to be symmetric about a plane. For example, I have a symmetry plane in my base plate part. And within the advanced mates, there's an option for symmetric. So we'll choose the symmetry plane, and then you simply choose two components. We'll choose the two cylinders, and click OK. And now these are symmetric about that plane. Similarly, I can come in, choose these two components, and choose this plane. But if you choose two components that can't have a symmetry relation because of where they're positioned, since these aren't really reflected across this plane, you're going to get this mating error and you're not going to be able to move anything. So I'll come down into mates, delete out that extra symmetric mate, and now this works fine. Our next mate type is the linear coupler. This will allow us to select out two faces, for example, these flat faces. And we could also choose a reference component, but in this case, this won't be necessary. And then we can specify a relation of how they move. So for my purple selection, maybe I want it to move 2 inches for every 1 inch that I move that face. So if we click OK, we can see now how those two move. I could also come back in and change that ratio as well if I want. Get it to move that full length. And for that mate, we can also reverse it and have these two go in opposite directions. For this mate, you'll just want to pay a lot of attention to the entities that you select, as this works the best with flat faces and doesn't necessarily work as well with other selections. The next mate type we'll talk about is a path mate, and I'm going to do a control drag to create a copy of this path cylinder. I'll go ahead and mate the cylinder and the plate coincident, and then I'll select the other cylinder as well. And make it coincident to the plate. So we'll set up 2 path mates here. And this asks me to select a component vertex. That's why I created this point at the bottom of the cylinder. So we choose that point and our path and click OK. And that'll allow us to slide along that path. And it'll stop the component at the end of that sketch. I'll add in one more path mate. Once again, I'll select this point. But in this case, we don't have a single spline. We have multiple arcs and a line segment. So we'll have to use the selection manager, and we'll choose the open loop option and select out that entire loop. And now this will follow that path. And the last of the advanced mates is the angle limit. It's a little bit more difficult of a mate to work with, but it works in a similar manner as the linear limit. So if we choose out a face and another plane, we can set the angle limits. So let's say maybe this will start at 0 degrees. And let's see how this moves. So if we had this going the other way, you just want to flip the dimension so that it doesn't pass through the plate as it moves. And let's try about 190 degrees. And see what that does. So we can just come in and modify this a little bit, maybe 165 degrees. (172), maybe 171 works in this case. So we'll set that as the minimum. And now we have angle limits on this mate. That's how you use the advanced mates. They're great for setting up motion within an assembly. And they're a lot more robust than the standard mates.